Hey everybody, Vade here, back again with another application problem. Let's get started here. In fact, oh my god, why do I keep talking before actually starting the problem? Like literally, you can even like prove this. Like even after like 3 minutes of time has elapsed in this video, you'll not see a single thing written on the paper. You'll just keep on hearing me talk and talk and talk and talk and talk about how this will be used in calculus, how this is so important in calculus, and how this exact problem will be there in calculus, but instead of sketching, in this case, sketching the graph and estimating the value for which v of x is maximum, you're not going to be sketching the graph. You'll be using calculus to do this. We're not going to do this step in this case in this problem here because it's not. This is very easy to do. But I do appreciate Ron and Paul. Oh my, I'm going to tell you, I'm going to keep praising Ron and Paul Battaglia, Ron Larson and Paul Battaglia on this problem here. They're giving us like everything. They're giving us the entire picture of the box like outline, and then they're literally folding it for us. Like Ron and Paul, Ron Larson, man, Paul Battaglia, man, you guys are like killing me. You guys are like giving the students like everything, man. It's like man, we are so spoiled these days, man. They're folding the box for us, man. This is crazy. Um, anyway, these two very important. That's why we're gonna go over A and B because this stuff you are expected to do in calculus, and this stuff is not easy to do. You need to keep on practicing these types of problems. That's why watch my previous two videos. Okay, you need to be using the given information. In fact, they're giving us, I think, a little too much here in order to actually, yeah, they're folding the box for us. Um, in order to actually, we need to find relationships between the x's, the y's, the v's, the a's, whatever it is, and that's really important, and it's tough. So we're gonna go over it. Okay, so this is another type of problem you may see even in calculus class. But again, the maximum part, you know. Anyway, an open box with locking tabs is to be made from a square piece with 20 of material with 24 inches on a side. This is to be done by cutting equal squares from the corners and folding along the dashed lines as shown in the figure. So, okay, let's think about this. They're literally folding the box for us. Okay, this is 24 inches. And by the way, let me step back for a second. Ignore this. Okay, you can verify at the end. Do whatever nonsense on a test. Do you really think your teacher is gonna give you this? No. Okay, let's be sensible here. Like, because the thing is, if you were given this, like, you could work backwards from this and like figure it out. Like the relationship is like easy peasy. Like once you look at this and like ignore this. I don't think it was really smart to give the actual equation. No one would really do that. Why would you do that? Tell me. We gotta start from scratch here. In fact, don't even give us the picture, but we're gonna use the picture because let's at least take advantage of that. Um, so let's let's not trick ourselves. Okay, let's not trick ourselves here. This is x inches. Let me use black marker here. This is x inches. 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 Yada yada yada. This will also be x. This will be x. This will be x. You get what I'm saying. They're x by x squares. So, if you want to tell me right now, this right here, the length, okay, or the okay, let's step back here again, okay, length and width are the same in this problem, okay. Last problem, I was like yapping for like 3 minutes straight, talking about that there is a big difference between length, width, and height. In fact, like because some people don't know like how dimensions, how to properly present them, and that length is the longest side. Especially in that problem where it literally just said length and didn't even tell you what the length was, what side they were talking about. Like, were they talking about the X? Were they talking about the Y? And it was the Y because why? Well, it was the longest side, so that's why the longest edge. So that's why I was trying to make that clear. In this case, yes, you can interchangeably use. Actually, I'm not 100. Yeah. Well, we'll see here. I'm just gonna let this be width and this be length. Okay. So with this being said, this is x inches. This is x inches. This is x inches. This is x inches. The width is just 24 minus 4x. No overthinking here. No overthinking here. The length. Guess what? It is. This is x. Remember, this is x here. This is x here. This is just 24 minus 2x. Great. Now, our height. Right here, h. This, again, we need to think about this. This is folded in. They gave us the picture. Folding. Folding is going on. What do you notice here? This is an x by x square. This is x, right? This would also be like an x by x approximately. This would be x tall, x inches tall. This would be x. The height is just x. So now putting this in together, all together, volume is just length, 24 minus 2x, times width, 24 minus 4x, times height, which is x. Now we can take a sneak peek at this, and what you'll notice here is that, wait a minute, this is not the same as that. This is 8x minus 6 times 6 minus x times 24 minus x. Well, this is factorized fully, okay? Because you see here, there's a GCF here of 2, there's a GCF here of 4. You see? You know, I'm pretty sure for this book in particular, there's like a thing called like WebAssign, and like, this is like, it's hosted by like Cengage Learning. If you look at the solutions, actually, even if you go to like the back of the book where they have solutions to the odds, like literally all of the answers are fully simplified, like fully like factorized, rationalized, whatever it is, and as they should, because like if you're professionally writing a textbook, you got to have the answers in the neatest form possible because it's the professional context, so academic context. So yeah, but of course your teachers, once you get into like calculus class or even this class, pre-calculus class, they probably won't ask you to rationalize. Be shocked if they do. AP exam, especially because they're trying to prepare you for AP, most likely, or I don't know about IB and how they do it there, but AP at least, they don't ask you to rationalize at all. But of course, keep in mind, I'm not actually completely sure about AP MCQs, but those are, I'm pretty sure, rationalized. So you do have to recognize rationalized answers. But actually presenting your answer in FRQs rationalized, as rationalized, is definitely not required. Anyway, so let's factorize here. This has GCF of 2, so I'm going to do, we could say, yeah, 2, because it's in the form, like, this has an, again, what am I doing? I'm looking at this, but yeah, I'm just trying to get it in this factorized form. Yeah, you know what, I'm not technically, like, going off of this to get the relationship. I'm just trying to actually get it to look like this. So I see here that there's no negative outside. Like, there's no negative something here. So technically I'm not cheating. So here I'm going to factor out a 2, so it'll be 2 times 12 minus x, and then I can times here, I can factorize a 4 here, so it'll be 4 times 6 minus x times x. Then we have a 2 here and a 4 here. This will be then 8 times then this additional x, so 8x times and I'm going to present it here 6 minus x times 12 minus x, because the multiplication, changing the order of multiplication, um, doesn't matter. So yes, we verified, again, really stupid of them to put the actual volume function here. Just say find the volume function as a function of x. That would have been fine. I should also put v of x here, but yeah. Hopefully you understand. They're just they're not trying to trick you. Like, this is x inches. This is x inches. This is x inches. This is x inches. 24 minus x minus x minus x minus x. 24 minus x here. No trick. And then height is also x. Ron and Paul, man, they were the authors of the book. They were really nice to fold it for you, okay? Hopefully you can visualize that this is how the folding will work. Okay, folding along the dashed lines. Okay. Anyway, let's now determine the domain. Again, I'm going to show the algebraic way, but you can also, at smart, especially in a test scenario, again, they can ask you they can technically ask you um, to show algebraic work to actually find domain, but I think it's more of a guess and check thing. That's really the most efficient way to do these types of domain. Especially never FOIL this out. Okay, keep it in the factored form. It is so much easier, even in the algebraic way of finding domain. And guessing and checking as well to see which values work. Like, this factor can't be 0 because anything times 0 would be 0. And again, this is where I'm saying it should be an open interval, because it's literally an open box. We're not on the Cartesian plane like with the first problem we've done in this series. It's an open box. Okay, this is an actual box. Okay, we have to assume, like, this is the actual box. They're folding the box. So this is, again, context clues, I would say. If they serve as context clues, they do serve as context clues as well. That the box has to exist. So we have the volume function. So let's algebraically then, like, let's find set each factor equals 0. So we'd have 8x equals 0, x equals 0. I'm going to write draw our number line here. This would be x equals 0. This would be our lowest value. And again, this v here, v of x, right, or v of x, we want it to be greater than 0. So that's why doing then this is some higher than degree 1 inequality. So I'm trying to use I call it the snake method. That's how I was taught it. But it's, you guys get what I mean. Like if you saw, like, from the previous, like, problems, I would write it like this, like this type of thing. It kind of looks like a snake. But yeah, very good visual tool. Always sketch the number line. You should definitely have a habit of doing that. In fact, I should probably write here v of x next to it. I've not been doing that in the previous problems because when you do derivative or increasing and decreasing charts as part of your derivative tests or concavity tests, you probably don't know. Maybe you know what concavity is, maybe you don't. You know, testing for inflection points, extrema, in calculus, you will need to label stuff properly. So, yeah, I think you can be okay with just drawing a number line for now. But justification is very important in calculus. Anyway, so this would be 0, and again, open circle here, because greater than 0. Then this would be 6, somewhere 6 here, and then this would be 12. Okay? Nope, did I do that correctly? Yes. So now I'm just going to write each of our factors, 8x, 6 minus x, and 12 minus x. So now negative 1, let's pick negative 1 here. This would be a negative then. I'm going to use the blue marker here. This would be negative, positive, positive. Okay, let's pick, I don't know, 1 here, positive, positive, positive. Then I'm going to pick like 7 here. This is positive, negative, positive. I'm going to pick 13 here, positive, negative, negative. Let's multiply the signs. This will be negative times positive, which is negative. Positive times positive times positive, which is positive. Positive times negative, which is negative, times positive, which is negative. Positive times negative is negative times negative is positive. So it'll look something like this. Our beautiful snake. Positive, negative, positive. So our domain will be something like this, and there is room. Okay, our domain, I'm gonna write it in both interval notation, and I'm gonna write it in first like the regular inequality notation, then interval notation. So this will be x is less than 0, or or no, not x is less than 0, positive x is greater than 0 and less than 6, or x is greater than 12. If you want to write this interval notation, it'll be 0 to 6 union 12 to infinity. So yeah, that's our domain. This is the algebraic work. Guess and check. I think guess and check is of course the most efficient, but if you're really stuck, there is a logical way of doing it, and that is through the snake method. That's what I call it. I do plan to make a video just going solely off of the snake method. Hopefully, you are familiar with solving any like higher degree inequalities. Though that's like an algebra 2 skill. I will still again, my focus is on calculus videos, but I'm only starting to make like pre-calc and algebra 2, algebra 1, geometry videos. I'm starting to make more of those. So I will definitely make a video. I made a video on the snake method like a few years ago, but then I think it was like one of my first ever videos, but it just got deleted somehow. Um, Maybe I can find that or like re-upload it or something. But yeah, it's very important to know, especially when solving these higher degree inequalities, because it's sort of like that backup way instead of guessing and checking. But that does work for a lot of cases, and it is a lot more efficient. But again, this is not a multiple choice scenario, so probably best to do it the logic way, I would say. But yeah, watch the previous videos if you haven't.